Welcome back. In the last couple of videos, we have discussed about the data types in detail. We have seen the last video. We have seen that floating point data types, where we can have three different variations. One is the single precision, another is second one is the double precision, and third one is the long double. And before that, we have also seen that characters and integers, and how we can print out the values, and we have also combined positive and negative values, right? So this video we're going to discuss about the modifiers more in detail. There are a few points we need to address before we proceed with the next topic. Our next topic will be in detail video how to take input from users. Okay, and also few more things we're going to introduce in the printf as well. But before we deep dive into the input and output, mainly we need to focus a little bit more on the data type point of view. So let us discuss these modifiers in detail. So first of all, let us understand why we call them these keywords are modifiers: short, long, unsigned, signed. Because see, the base data type, what is our base data type? Okay, our base data type is one integer, another one is character, and the third one we have, I have not listed here. I'll tell you why it's not listed here. Floating point type, right? So under floating point we have three variations. One is the float, second is the double, and third one, after combining with these modifiers, we will have the long double, right? So we need to understand here why they are called modifier, because if we add any of this four listed here, short, long, unsigned, signed, any of these with this base data type, their basic property will change. Okay, so what is the basic property will change? Basic property will change, many things are here. First of all, the size will change, memory requirement, or that might be the a type of value. Okay, a type of value it can hold, positive and negative value, so that can also be controlled. And also if I just combine with this short integer here, so it will take half of the memory requirement only, because integer takes 4 byte and short integer will take 2 bytes. So you can see the modifications, right? Similarly, if I take long integer, so it will be taking 8 bytes. So see the base, either in the point of view of memory requirement and the basic characteristic, and in the point of type of value it can hold, that will modify. Similarly, here other two also fall under this category, signed and unsigned. Signed represents both things. One is the negative value and as well as positive value, and unsigned represents only positive values. Remember here, these two data type, integer and character, what is their default nature? Their default nature is they are signed. Okay, this is the default nature. So if I simply write integer and if I write signed integer, both are same. Okay, similarly for character also, if I write character and signed character, they are also same, right? So now let's go back to the compiler or online compiler and see their demonstration, how we use them. Okay, so let us just go to the create a new project here. We need to select the language, right? Let me just check our recording is on. Yeah, fine. And yeah, don't record these comments. We have already seen how to utilize the comments. Now let me show you these modifiers step by step. Just modifiers, where you're going to save this. You're going to save it here. Fine. So if I just write a base data type integer, suppose I have assigning a num 8. So see, I did not use any modifier before that int, right? So it can have positive as well as negative. Here you can check it. If I just print these values with the correct format specifier, okay, so here it is printing the positive value, and if after that if I modify the value of num, suppose now I'm using -9, okay, and then again if I print, okay, again I print, just save and run, you can see it represents both positive as well as negative value, positive as well as negative values. So there is no information loss, and whatever the base characteristic, the 4 byte it consumed, and it represents both positive and negative. Similarly, if I just add the signed modifier here and run the code, see there is no change in the output. Okay, so as we have seen here, as I've mentioned here, that if I write integer, or if I just write signed integer, okay, both will be same. Okay, it can also take positive, it can also take positive, it can take negative, it can also take negative, right? So it is not going to adding an extra information over there, but only if you look at carefully this line signed integer, it just qualify my code as a more readability, more no meaningful code or statements it can be. So anybody can understand by saying that keyword which is preceded the int keyword means that num can have any kind of values. Now what about the unsigned? Is it true for the unsigned? So let us see. So for the unsigned I have used here 3, and let us just print it. So let us just print it. And now suppose I'm going to modify it. Previously it holding the positive value, now I put a negative value, and now if I print it again, okay, so look at the values here. Signed integer have 8, so I get the correct output, and once I update the signed integer to -9, so again I getting the correct output. Similarly for the unsigned integer, when I have assigned the value as 3, it give me the correct output, and when I modify the value -4, it give me the correct output. But hold on here, look at the format specifier I have used. I have used the format specifier here %d. So %d is for integer, it is doesn't specify the sign, either as signed or unsigned. Okay, so now let us replace those %d with that respective format specifier. So let me just add a more meaningful output string here. So I'm printing here num. Okay, so num is signed, so for the signed integer we can use %i, right? And this will be the value for the val, which is unsigned integer here, so we can use %u, right? Similarly here also, if we just update this, and then we'll check are you getting the correct output or not. Okay, there is a \n. Okay, now see, when I use %u and %i for the signed integer, I get 8 correct output and -9 also as a correct output, no problem. But look at the unsigned one. When the value is positive, I get it proper output 3, but when the value is negative, I did not get the proper output, I get something else. Okay, we are expecting -4, but we are not getting -4, we are getting some positive number. The main reason, what is the main reason behind this? Okay, see, let us understand it. What is the main reason? The main reason is whenever we talk about the value, a value comes in two range, no, the positive range and the negative range. This is our negative range, this is our positive range. So we are talking about the characters and integer, and it is also true for floating point. When you mentioned unsigned, so unsigned fall this category here, and but when you talk about the signed, signed covers all. So it can easily understand the positive and negative value because it has the knowledge. You can see the signed range of signed covering, right? And on the unsigned, it only have the positive range. Only it can represent positive value. So in the code, if I even though I write val equal to -4, okay. So we have written that val equal to -4, but the -4 is totally outside of the range that an unsigned, okay, an unsigned integer can represent. Okay, so it is also so what is happening now, whenever you take a negative value for unsigned integer, it will try to accommodate this value within this range because this range is known to the unsigned integer. Okay, so now let us see with the short integer. You will understand how these values are mapping. So let me just show you one thing before I move to the short integer. So let us just print the highest in value that an unsigned integer can have. Okay, we have already seen the use of limits.h. So further for the verification purpose, so let me just print here highest or the max unsigned equal to percentage u, and if I use here unsigned integer max, and if I just execute this, okay, so now look at the values here, so you'll understand the process how it's actually works. What happened, the pen, yeah. So now this is the maximum value an unsigned integer can print. Okay, let's write it here, 4294967 but what value that we have kept here, we have assigned -4. Okay, -4 is unknown, this positive value is known. So what it prints this one. So what is the relation? So see, if you just go back, so it start assigning the value from this side. Okay, whenever the any value appeared as an unknown, okay, start assigning from this side. So this is the highest value it can have. So how it is manipulating, so if I just subtract this number that I have assigned to val, so what is the value here? So this will be the value. So it added 1 because range started from 0. So I hope you know that now it is clear, range started from 0. So 1 reserved for this purpose. Okay, so now if I just add this value with 1, I get this value back. You can also try with other values. So let us just check with the other values here. So if I, instead of -4, if I use -10, and now if I just execute it, so you can see how it is working. Same if I just deduct 10 from here, okay, so the value will be, last two digit will be 85. If I do +1, so result will be 86. So you can see the results as an 86. Fine. So okay, so now let's move to the other signed and unsigned category. So now another point here, we need to remember the default behavior of the integer that I mentioned. Whatever you have written a signed integer num, even though if I just simply remove this signed from here, it is same as, so keep in mind, it is just to make you understand, yeah, same as signed int num equal to 8. Value is not important. The type we are mainly discussing with the modifiers, right? So whatever you write, if you write this one, if you write this one, it is same. So similar case on the other side, if I just use short one also. So suppose if I write SIG and it is signed short, okay, integer equal to, suppose as equal to some value 9. Okay, so signed also can be considered positive as well as negative. Okay, so let us print these values. So for the short integer we are using for the short integer we are using the format specifier as h, and if I want sign I need to do this way, percentage hi, and if I want the unsigned one it should be hu. Similar case here as well, it should be hi. I'm going to modify that code, don't worry, I'm just updating that required format specifier. Okay, we're going to print the exact value. So I have used a signed short integer s, so let me just use unsigned short integer val. Okay, so now that only now I need to change. So if I change it to s, fine. Similar case here. Okay, so let me just make it modify. Let's just put this one in comment. So I modified the val. So s equal to, if I just assign a negative value, -7. So let's see what is happening. And here instead of num, if I use s, okay, so and we need to print the short shrt, I hope so it is correct, the constant declared in the system limit.h. So here you can see the signed value that I have used. Okay, what is the signed value I have used? 9. Okay, so we get the correct output 9, no issue. Unsigned is 3, so it is also print me 3 with the short integer, no problem. But when I come back here, when I modify the value with the negative, signed one is 7, so I also get 7. It is not num actually, I am printing here s. Okay, so num I've used in the previous examples, here also s, so do not get confused. And here the val I am using -10, but instead of -10 it prints me this. Okay, because it only knows the positive values. So here also same, this is the maximum value it can have on the positive direction, so it start accommodating from this direction. Okay, so you have 10, so if I just subtract this it will be 65525. If I do +1 it will be 65526. So this is the value it prints. So the concept remains same. You are using a short integer or you are using integer, there will be no change. Even though suppose if you are using long integer also, there will be no change. Okay, so now next part is here, this assigned short, it is also same as if I just only write short as equal to 9. It is totally same, both the statements. There is no further no difference, no issues over there. If you can only write short as, but remember for the unsigned it should be qualified, the statement should be qualified with the keyword unsigned. Unsigned cannot come as a default, it is always a changing nature, so you have to mention that particular term. Okay, so it is also true for long integer as well. You can if I just write only long, so let me just show you. If I just only write long l equal to some large number, if I have taken, okay, fine. And now if I just want to print that particular one, so we are using percentage ld for the format specifier as a long, and if I just pass here l, so let us just check the value. So we get the value here, whatever value we have given, and similarly I can also do the negative stuffs. I change the value, you can see the values is negative, there is no problem. You can achieve the same thing by adding signed long. So I get the negative value, right? And you can also have the positive value as well. But if I just 1 minute, okay, if I just use unsigned long L and I try to print a negative value, let's just execute this. See, so okay, instead of, and to change the format specifier, it is percentage lu. Okay, now see, when I use percentage lu, the value move to the positive direction. Okay, remember percentage d can handle both positive and negative. Okay, so if you want to see the exact behavior of the data type along with the modifiers, you need to use the respective format specifier reserved for that type. Okay, if I here just if I use percentage ld, I'll get the correct output, no issue, even though I've written the unsigned, fine. But if I use percentage lu and if I just execute this, you can see it try to accommodate the value in positive direction. Okay, and on the other side, unsigned positive, unsigned long also cannot have the negative. You always must go with the positive values, right? So you can write this. So now it is correct, and this one is same as signed long int. Okay, L equal to, let me just copy the value, else I'll just get little bit confusion here. What is same? So totally same, there is no change. If you want the unsigned, you just write unsigned long. Okay, int keyword is not necessary, long will take care. So if I just want to use, okay, positive values, you can do that. More specifically, you can mention it, right? Similarly for a character also. So let us check character ch. I am assigning a value a here. Okay, so you can ask now, so where is sign here? So in the previous few, if you go back to the one or two more lecture, you will find where I've seen the typecasting between the integer character. So instead of character, if I just assign the integer value, okay, and then if I just print it, because it is very small value, so better to use h here, right? So if I use hi for the signed case, and if I just pass this value ch, the variable here ch, and backslash n, and run it, you see is the output. Some issues. Unsigned long lu, too large for its type. Okay, let's me just handle. I did not check the highest value it can have. Okay, now see there is no more warning. So now here you can see when I use 65 is a positive 65 I have used, and I did not mention either signed or unsigned before the character, and I just consider use the format specifier hi. So h represent for the short integer and I represent as a signed. Okay, because in character we don't have separate format specifier as a signed or unsigned character. So that's why I'm using with the integer here, short integer. You can see the correct value that I've used. So even though if I use minus 65 here, so it is also correct. You can check the output. Minus 65 is correct. What if whenever I just change this one to unsigned, and if I just now execute, now see it is not giving me the minus 65, so it try to accommodate in the positive value, same thing that we have seen. So it will be subtracted from minus 128 and minus 127 to minus unsigned, sorry, unsigned, it will be started from 255. So 255 minus 65 plus 1 you do, you will get this value. Okay, so in this case, if I just remove this sign, you will get the correct output. Now say 65. So remember, it can have unsigned, it can have only positive values. So now if I just write signed char, just what should I write, ch2. Okay, so it one similar, so it is same as char ch2. Fine. Now, what about the float? Can we use, as I mentioned here, this modifiers are not applicable with the float. So here I have written the float separately. Okay, I did not write float here. Okay, so this modifiers, none of the modifiers has been applicable with any this unsigned and signed. Okay, and the short is not applicable, okay, not applicable with any of these two type. Okay, we cannot write signed float, signed double, unsigned float, unsigned double. Long is applicable with the double. So just to change the range, right, long double, so it will take compiler dependent 10 byte, and some compiler may take 14 byte of memory, so it will allow you more number of range for the precision it supports. Okay, so this is the only one modifier that is allowed with the float, only the long one, but not with the exactly the float, with the double only. Okay, floating point, under the floating point we cannot use unsigned and signed. So let us just write and demonstrate. So I'm writing here signed float f. Okay, and then I'm writing unsigned float ff, right? Similarly, signed double d and unsigned double dd. So if I just save and I just run this, you see the error here. It is saying that not allowed. Okay, so this not allowed, simple. So no need to use, and remember the default is again signed here, unsigned is not allowed. There is a reason, unsigned is not allowed. If you remember the floating point data type that we have discussed, they have a three part. Now one is the sign bit is there. Okay, then mantissa part is there, and exponent. Okay, so these are the three part a floating point number have. And when you remember the exponential form, so after the e it either come with plus or either it will come with minus. So after the e it start with a plus for a very large values, and after e it will start with minus for the very small values. So again, if I just consider the unsigned one, unsigned cannot have the negative value, so this may be the reason. That's why they did not allow unsigned. So and it keep as a default as signed, so it remain as signed. You can use the sign, or if you cannot use the sign while assigning the value, so if I write f equal to -3, it will be treated as negative value. If I write f equal to only 3, it will be treated as positive value, right? So this is all about the modifiers. I think it is okay, very small topic, but very too much informative. You just keep these points in your mind. Okay, so I hope it is fine.